So, hello everybody. I'm really glad you come, and there is no empty room. So, my name is Vojtech Cima, and I came here from Switzerland, from ICC Lab. And today I would like to tell you something about the performance analysis of live migrations in OpenStack. So, let me introduce me. I'm a student at Technical University of Ostrava, and currently I'm working as an intern in ICC Lab at Zurich University of Applied Sciences. About our lab, we are the Cloud Computing Research Lab. The lab is led by Thomas Michael Bonert, and we have three main initiatives we are working on. This is the Infrastructure as a Service initiative, Platform as a Service initiative, and energy. This is the field I'm working on. And we also transferred the research into the education because, after all, we are the university, so we have classes for the students interested in cloud computing. So what's the motivation for live migration in OpenStack? In the bigger picture, our goal is to develop energy-aware load management, and we use the live migration as a tool for it. Because the live migration can provide almost any downtime, it's good to have the tool like the live migrations to be able to move VMs without customers noticing it. So it provides a more fluid load management than, for example, the standard migration where you have to suspend the VM and move it somewhere else. And of course, in the bigger picture, we need also the other services, which are the server and VM energy profiles. One guy is working on it from our lab as well. He's using Ceilometer and Quappy. And also you need rating and charging and billing systems. And I provide URL also for this. So we have a special guy who is working on that. So what's the current state of live migrations in OpenStack? You have two options. You can work with the live migration and the block live migration. The difference is simple. If you use live migration, you need to use shared storage for your VMs. For example, NFS or Ceph. And if you migrate instances using live migration, you are migrating just the VM states, and the VM disk is shared on the shared storage. While the block live migration migrates the disk as well through the network. So you are migrating VM states and VM disk through the network, which can lead to the failure. If there is something wrong with the live migration, you can lose some data because data are usually stored on the disk. So it's better to have your disk, some dedicated disk attached to the VMs. Here is some basic information about our testbed. We are using mid-range 3-node architecture with one controller node, one computing node, 2 compute nodes, and all connected with the 1 gigabit network. The servers are IBM X3550 M4 with each 2 times Intel Xeon E5, 192 gigs of RAM, 2.7 terabytes. We deployed Mirantis Fuel with OpenStack Icehouse. As a hypervisor, we are using the libvirt and QEMU with KVM support. What we cared about in our test is what everybody should care in if you are doing live migration. This is the migration time. This is basically the migration duration. You can easily read all the information when the migration was started and when did it end up in the Nova compute log or Nova all log. And it's not so difficult to count how long does it take on the OpenStack level. Downtime is another very important aspect of the live migration because not everybody is willing to have such a huge or even big downtime during the live migration. And for examining the downtime, we use just basic ping tool and ping the VMs and tried how long is it unreachable. And also we measured data, how much data was transferred during the live migration, but because there's not so much time here in the session, so I will focus on the migration time and downtime, and you can find all the results on our web pages. So first of all, we try to spawn various flavors of VMs from tiny to extra large, and on the essentially unloaded servers and essentially unloaded VMs, you can see on the charts the migration, live migration is a matter of seconds in both cases, in live migration and block live migration. But what's more interesting, that by default, the live migrations provide the constant downtime, while the block live migration downtime increases with the migration time. Here is more interesting scenario. It's known that live migration, just the standard live migration, has an issue. It doesn't converge if the memory pages gets dirtier faster than you can transfer that to the destination. So the live migration, as we know it today, can stack. People are working in QEMU on the new method to live migrate instances, but this is like a really feature work. So with the increases VM load performance gap between the BL and block live migration decreases, you can see that if you stress increasing amount of memory, I should start with that. So we use a stress tool to stress some amount of memory on the VMs. And as the amount of stress memory increased, it led to the longer migration time. In the live migration case, we were able to migrate instances up to the almost 100 megabytes of stressed memory. Then it wasn't able because of the issue I described before. But the block live migration, we were able to migrate almost everything, no matter how high load was, because by default, the block live migration just suspend or pause the VM during the migration. We also tried to add some additional data on the inferral disk, and in our cases, with each allocated gigabyte of the disk of VM, it took, for live migration, 9 more seconds to migrate it, and for the block live migration, it was approximately 18 seconds to migrate it. Downtime stayed all the time the same for the live migration, and also you can see that for the block live migration, the downtime also increases with the migration time. We also try to load the environment. So with the environment load, we generated artificial network traffic really high, 900 megabits per second, but the decrease of the performance of live migration was approximately 30%. And there's a question of migration traffic priority because the decrease wasn't so significant. And we also tried to artificially generate the CPU load. We loaded some 70% of the cores, and we noticed 20% performance decrease. So takeaways for our scenarios, the scenarios will differ depending on your network, on your setup, are that the live migration is approximately 40% faster than block live migration. It provides constant, almost zero downtime, which can be set as a QEMU parameter, but it's not set it up. It's not able. We are not able to set it up through the libvirt yet, so we have to deep dive a little bit further into the QEMU. But disadvantages are that it might not have converge, and it requires shared file storage. While block live migration is more reliable, but it has increasing downtime, which is approximately 75% of migration time. Our current and future work. As I said, we would like to continue with the performance analysis of the post-copy live migration with the new QEMU, with the new Unix kernel 3.18. There's a 3.18 RC release candidate 2 kernel available. And in this case, the RAM memory is copied from the start to destination on demand page fault, so there shouldn't be the converge problem anymore. And in the bigger picture, we are developing the energy-aware load management. So this is basically live migration automatization based on servers and VMs energy profiles. Thank you very much for your attention. If you have any further question, don't hesitate to ask. Otherwise, you can find all the results on the web. So if you are interested, follow us on Twitter. Thank you.